Okay, so when one of the things that I always really place a focus on in my class, all my math classes, is the importance of memorizing things. So when you see in your textbook that you now can learn about the derivatives of trig functions, this section is from your 2.6 lecture notes. So you're watching the freestyle, then you're going to watch the lecture notes. Mr. Taylor has organized these trig functions in a way that's unfamiliar to me. So I see what he is showing and why he shows it in this order. Notice that if your trig function starts with a C, he wants to point out to you that all of those derivatives will be negative. And so I kind of like that, right? I also notice that he's organizing each line like, hey, if you think about the derivative of sine, you get cosine. So then is it natural for you to think of the derivative of cosine as being negative sine? Tangent, you're going to see in the lecture notes how I got this derivative, but the derivative of tangent is secant squared x. And in your mind, can you organize this to think that the next derivative should be cotangent? And notice how a secant squared x turns into a cosecant squared x. That's it, fascinating. And also that it becomes negative. I do not go over this proof. I believe this the proof of that will actually be in your homework. The derivative of secant is secant tangent, and again, that seems crazy, right? That if you start with a secant function, that after you take a derivative, you end up with two trig functions. How much more complicated could it get? But if you can get used to that, which I'll show you how to get that derivative in the lecture notes, can you then memorize that the derivative of secant, okay, we get to secant tangent. Well, when we take the derivative of cosecant, we also get, ready, cosecant and cotangent, but just throw that negative sign out there in front. So what is the purpose of this freestyle? It is literally for you to choose which of the two things that you are going to copy 5 times. Remember, that's my method for memorizing stuff, and I believe it's very effective for a lot of students. As usual, if you want to make flashcards, that will be worth extra credit because that would be doing extra. And so maybe you don't organize those thoughts in your head at all, right? Maybe you just freestyle memorize them because you have them from flashcards. But me, I organize things in my thoughts, like basically when I've read it a certain way, that's how I have it be memorized. So I've gone over Mr. Taylor's way of organizing this. I wanted to show you the way that I organize it because I do not organize it like this. I would not copy this table. This table this is just not how my mind thinks about sine, cosine, and all that. So I wanted to review for you that if you had me for math 2, I taught you that sine of x was opposite SOHCAHTOA. Remember SOHCAHTOA, opposite over hypotenuse. Then I taught you that cosine of x was adjacent over hypotenuse. And then I taught you that tangent was opposite over adjacent. Now, if we were in math 3 together, I would have also then taught you that cosecant of x is going to be hypotenuse over opposite, which is the reciprocal of sine, and that secant of x is going to be hypotenuse over adjacent, which is the reciprocal of cosine, and that cotangent of x is going to be adjacent over opposite, which is the reciprocal of tangent of x. Now this helps us when we move on to actually learning about pre-calculus, and we want to remember these reciprocal identities. And specifically, back in the day, calculators did not have these functions. There was the button. They didn't actually make calculators that had the button that said cosecant on it, or a button that says secant on it, or a button that says cotangent on it. If you wanted to use a calculator to find cosecant of x, you had to know that it was the same thing as 1 over sine of x. And if you wanted to find secant of x, then you would need to know that that was 1 over cosine of x. And then for cotangent, you would need to know that it was 1 over tangent of x. Now, the other reciprocals are definitely there and can be used. These are just not as popular. So this is sine of x is the same thing as 1 over cosecant of x. And that cosine of x is 1 over secant of x. And then tangent is 1 over cotangent of x. So they're true, we just don't really need them because, calculator, if you want to find the sine of something, you can just press that button and find it. I will mention, though, for pre-calculus purposes, it was also important to know that tangent is the same as sine of x over cosine of x, and that cotangent is the same as cosine of x over sine of x. So writing these is very tedious, and it seems I wasn't recording when I was writing it. So here it is. The derivative of sine of x is cosine, and that the derivative of cosine of x is negative sine, and derivative of tangent is secant squared. Cosecant has a derivative which is negative cosecant cotangent. The derivative of secant is secant tangent, and the derivative of cotangent, is negative cosecant squared. So when I write it in the order that I'm familiar with the sine and the cosine and the tangent, and then the cosecant and the secant and the cotangent, I feel like it just flows because that's the way that I had it memorized. You can memorize it any way that you want to, okay, or organizing it in some sort of fashion that helps you with your memory. So I wanted to mention to you that if your trig function starts with a c, it will have a negative derivative. If it starts with a c, it will have a negative derivative. If it starts with a c, it will have a negative derivative. And hopefully you now will feel comfortable copying this. Again, you can organize each one of these functions in whatever fashion that you want. This, again, you can organize these in whatever fashion that you want. And this, you can organize these in whatever method that you want. But this is what I wanted to have be done for the Copy 5